Hello, AP Stats. This is Mr. Kim here with Chapter 12 review for chi-squared. This is going to be a short chapter with a very short quiz that you'll be taking tomorrow. And without any further ado, let's get started. So for number 1, each fruit fly litter consists of 100 fruit flies. Expect half to have red eyes. So what we are expecting, every expected value is 50. And then when we took the 4 samples, we get 60, 80, 20, and 10. What is the chi-squared value? Remember, for chi-squared value, it's the summation of all of your observed minus expected squared over expected. So you can just simply subtract the values from 50 for each of them. So 60 minus 50, because that's the first observed value, minus the expected, which is 50, divided by 50, because that's your expected value. Oh, don't forget to square that as well. Plus 80 minus 50 squared over 50, plus 20 minus 50 squared over 50, and then plus 10 minus 50 squared over 50. And that should get you the final answer at the very, very end, which I do believe that the answer here was D. When you simply put this into your calculator, you should be able to get 70 from that. Number 2, which of the following is not true of the chi-square probability density function? So we're talking about not true. For small degrees of freedom, the curve has right skews. That is absolutely true. Every chi-squared value, it depends on your degrees of freedom, but they always tend to have this skew to the right distribution. As the degrees of freedom increase, the curve approaches the normal curve. That's also another common characteristic, or the most renowned characteristic of chi-squared, that as the degrees of freedom increase, that the curve approaches more of a normal curve like this. Chi-squared is defined only for positive values of any given variable. Every single time when you do get the counts for these, they are all going to be positive values. So yes, that's absolutely going to be true. The total area of any distribution is always going to be equal to 1. So the only answer that's left for is E. Remember that the chi-squared value can also be used for categorical data, tests for goodness of fit, homogeneity, as well as the independence, and they could be potentially be categorical variables. Number 3, there are 4 surgical methods currently being used to place various medical implants in patients. Patients will be monitored and their pain level recorded as severe, moderate, or mild for 1 week after implant. What are the degrees of freedom for these 4 methods and the pain level? So we have 4 surgical methods, so there will be 1, 2, 3, 4 this way, and there are 3 of the severity of the pain level. So remember that it's always column minus 1 times row minus 1 for your degrees of freedom. So that'll be 4 minus 1, 3 minus 1, that'll be 3 times 2, which is 6. How will the expected count for the peanut M&Ms be determined? So peanut M&Ms is a green peanut M&M, sorry. So that'll be green and peanut this way. And to figure out the expected value, expected count will be row total times column total divided by the total, which is n. And I have no choice but to just add them all up here. So 8, 6, 8, 25, 5, 7. That's 37 plus 22, I believe. 37, 20, that's 59 this way. That's 47 that way. And unfortunately, I will have to just add everything up here. So it's 29, 35. That's 33, that's 29, that's 28. So I'm going to rely on my calculator here for a bit. So to find out the total, 35 plus 35 plus 33 plus 47 plus 29 plus 28. So I get total n to be 207 for this one. So if you recall, our column total was 47, our row total was 59, and our n value, which you can see in the calculator, is 207. So I'm literally looking for this, which I believe the correct answer here matches with D. Number 5, what are the correct degrees of freedom for this table? Again, refer back to question number 3. That's row minus 1, column minus 1. I believe we have 6 for column, so that's 5. Row would be 3, so that's 2. So degrees of freedom is 10. Okay, so here is the explanation for number 6. For number 6, for this table, M&Ms will be the appropriate set of hypotheses. Well, first of all, you have to understand that this is going to be a chi-square test for homogeneity, because what we're trying to see is, are there going to be any differences for in the distribution of the colors for each different types of M&Ms. So for the null would be that there is no difference, blah, 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 blah in the context. And then the alternative is that, yes, there is a difference. So understanding that, that's the word that we're looking for when we're doing chi-square test for homogeneity. For associations for any of these kinds, that's all for independence. And independence, the major difference between the independence to homogeneity is that for independence that you actually do have one random sample, like people, and then we separate it by males and females. That's the classic one. That's also in your example for the packet as well. For this one, you have different set of M&Ms. Like we have plain, we have peanut butter, and we have basically separate independent random samples rather than having one random sample and separating it based on gender or kinds or whatnot. So because we have multiple random samples, and then actually I have to put the word independent, multiple independent random samples, plain, peanut butters, blah, blah, blah. We are not looking for independence at all. So A and B is not correct solely because we're not testing for independence. The proportion of M&Ms, that is not a word that is associated with any of the tests that we have. Goodness of fit, we're trying to see if the proportions are going to be the same throughout. So this is usually meant for goodness of fits here. Because we're doing a chi-square test for homogeneity, the word here that we're looking for is a difference. So there is no difference in the proportions of M&Ms by color, and that there is a difference. So here the correct answer would be E. Number 7, what will be a valid conclusion based on the table of M&M values? So to get this chi-squared value, you not only do you have to get all of your observed minus expected into your matrices like A and B, that's just a lot of work. So it's kind of lucky that all the answer choices have the same chi-squared value. So you don't really have to look for that, nor degree of freedom. We all have 10. So what really comes down to is what's the value that we're going to get with these two values intact. So if you go to your calculator, we definitely do want to get some p-value for this. So second vars, and then if you go to chi-squared CDF and then plug in those values, 22.9, because what we're dealing with is that the chi-square value is 22.9, and then we want to figure out that p-value that is as extreme as 22.9 or above it. So we're going to put 99999 for the upper. Degrees of freedom was 10, and then so we press paste. And so we get our p-value of a very, very small 0.01. So now it's normally accepted that alpha at 0.05, that is less than alpha. So that is the story that we're looking for, that p-value is less than alpha. But we're still going to look through every single one of the choices and pick the best one. There is insufficient evidence to reject the null claim that the proportion of M&Ms is the same for all colors. Well, remember, our p-value is extremely low, so the chances are that we are actually going to reject the null hypothesis. So that there's insufficient evidence to reject it, I don't think that's going to be true. With chi-squared, blah, 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 there's a strong evidence to reject the claim that the proportion of M&M is different for each color, and the claim that the proportions are the same. So here, actually, that the null claim is actually from here, that there is no difference. So there's a strong evidence to reject the claim that the proportion of M&M is different. No, we have to reject the fact that there is going to be the same, because the null saying is that there's going to be no difference. And if you're rejecting the null, you're rejecting this claim right here from answer choice E from the previous question. So this is not going to be true. With chi-squared of 22.9 degrees of freedom of 10, there's a strong evidence to reject the null. In other words, there is a difference. Yes, because we are supporting the alternate hypothesis stating that there is going to be a difference. There's a strong evidence to reject the null. There is absolutely no association. Wait a minute. Association is for independence, and that is not the test that we just ran from the previous question. So D is out. And E also says the same reason for A, that there's insufficient evidence to reject the null. So number 7 should be C, yes. Number 8, the cupcake store believes the half of the cupcakes sold are chocolate. The remaining half sold seems to be equally divided. So we have 3 flavors. If the order has been placed for 300, how many should they expect it to be cherry? Well, 150, 75, 75, half are chocolate, the rest are vanilla and cherry. So for cherry, it should be 75. That one was easy. Number 9, random sample of patrons of a local mall. So we have males and females. See, this is a key thing to notice. Usually when they give you like gender like this, that means that you have actually one singular independent sample, which is the public smokers. We are trying to find a random sample of patrons. So they all came from patrons, one independent random sample. It's not like we have different types of independent samples. So for this, we're trying to test for association/independence. And so if you're going back to figure out what the null and the alternative for these are, there's absolutely going to be not a difference for, so that there is no association between the two of the categorical variables stated, gender versus the whether they're agitated or not by public smokers, and that there is going to be an association. So that is what we're looking for. So here, when you guys take a look at the answer choices, gender and agitation due to public smoking are not independent. We are looking for the word association, but then E is just the complete opposite of what we're trying to say. There is no difference in gender and agitation by public smoking. This is mostly for the homogeneity. Knowing people are agitated by smoking indicates that is just clearly not even one of the templates that we have for null and alternative. So we're really looking down between these two. So let's think about this. If there is no association, it means that they are independent from one another. If there is an association, that means that they are not independent from one another. So we're looking for independence for null and not independent for alternatives. So the correct answer here for number 9, just to verify, should be B, and which is correct. Number 10, a local bagel shop makes 6 types of bagels and 8 types of cream cheese topping. So I can already tell where this is going. Degrees of freedom, it's always -1 from row and column. That's 5. That's 7. Multiply them, that's 35. 11, is there convincing evidence at significance level of 0.01? So since we have all the p-values that are the same, I'm assuming that the math at the end of the day, you're going to get 0.001, which means it's extremely lower than the significance level of 0.01. So we are rejecting the null hypothesis. Is there a significance evidence? Yes, that there is a strong evidence or convincing evidence for alternative hypothesis. So here what we have is we were asked to see if the continue to support the healthcare reform. So support or not support, and then based on their political affiliation. It seems like we have just one random sample here, which means this is checking to see if they are independent or not. But we'll go through all the answer choices. So let's read A. There is a strong evidence that political preference and support are independent of each other. In other words, knowing their political preference gives no insight. Now, if you go back to this, remember that the association/independence, the null hypothesis should always say independent, and that the alternative is not independent. Since we rejected the null, we have a strong evidence to support that they're not independent. So if you go down here, there's a strong evidence that political preference and support are independent. Nope. Remember that the alternative says not independent of one another because there is going to be an association. There is a strong evidence for answer choice B. There's a strong evidence that political preference and support are not independent, so that looks good. In other words, knowing their political preference gives insight into their support of the... Knowing their political preference gives insight. Well, if they're independent of one another, knowing their political preference gives insight into their support of the increase. That shouldn't be, because we don't know what their political affiliations are, but then they're not independent, which means, oh, right. So if they're not independent, that means that there is an association, which means knowing their political preference gives insight to the support. Yes, that's absolutely going to be true. There is strong evidence that political preference and support are independent of each other. We have already established that that is not going to be the case, because answer choice A also says the same thing. There is insufficient evidence. That's not true, because we do have convincing evidence. P is less than alpha. There is insufficient evidence once again, so 11 should be B for this reason. Number 12, which is not true for chi-squared homogeneity test? This one I think I particularly had the most trouble with, because for chi-squared homogeneity test, we have the rules for H sub O and H sub A, but for these three, they all kind of sound really good. Chi-square distribution is right skewed. This is not going to be true because it depends on the degrees of freedom. You can also have a normal, more close to being normally distributed curve based on your degrees of freedom. So because of that reason, I'm going to eliminate anything that has 3 in it. Data is categorical in nature, and degrees of freedom is calculated using k minus 1, where k is the number of categories. Number 2 is absolutely going to be true, because that is how you find out the degrees of freedom. Yes, I understand that if you have row and column, you have to subtract 1 and multiply them. But as long as degrees of freedom is minus 1, and if it states that, that's what we're doing for row and column. And for number 2, it is unclear, but that's all they're saying. The degrees of freedom for one category is calculated by subtracting 1. So 2 is absolutely going to be true, so D is out. Data is categorical in nature. Remember from the previous that the data can be quantitative. It's just that we have a lot of categorical things that we're doing. So the correct answer for number 12, I believe, yes, they said it was E. It could be quantitative. And I believe we have done a question like that from before. Let's see. The chi-squared is only used for numerical data sets, right? So for number 2, not only can you use it for numerical, but you can like categorical, obviously. For this particular question, in nature, the data does not have to be categorical. It could be quantitative, but we don't really see a lot of examples of that. So the answer here for this would be E. All right, number 13, 2 different cereal companies. So we have all of these numbers, and it seems like we have p-value of 0.22. C is completely wrong because that makes no sense. So if P is greater than alpha, it means that we fail to reject the null. Okay, so we have 2 different cereal companies, and then we have 300 potential customers. Cereal companies, company A and company B. So we have 2 independent samples, which means this is checking for homogeneity here. So the null would be is that there is no difference, and then the alternative will be is that there is a difference. Just to double check, if you go up here, there is no difference, and then there is a difference for chi-square for homogeneity. I suggest study this, how to state the null and alternative. Honestly, if you forget what to say for those, then it's going to be really bad. So there is no difference, and there is a difference. Because we failed to reject the null, it means that there is no difference. There is no difference in the cereal selected for either company brand. There's no difference in cereal chosen by the brands as P is greater than alpha. There is no difference in cereal selected for either company brand. There is a difference in cereal chosen by brands as P is greater than alpha. Well, what we're trying to say is that there is absolutely no difference between the 2 variables that we stated, that it doesn't depend on the company, nor does it depend on the cereals there. So there is no difference in the cereals, and so it's D and E is out because they're saying that there is a difference in cereals like for each company brand, and there is no difference in cereal chosen by brands as P is greater than alpha. Yeah, so it should be A for 13. Yeah, that's the only one that makes sense. They could have phrased this a lot better. Number 14, if the manager wanted to see if there might be an association between the type of movie and snacks sold, Alrighty, so children's movie and action movie, they want to see an association. I mean, I guess that really just kind of gives you an idea. That's for independence, yes. For 14 is C. Is there evidence that the type of movie and snacks are not independent? So we have, all the chi-squared values, thank God, I don't have to solve for it. Row is 3, column is 2, column is 3, row is 2, subtract 1, that's 2, that's 1, so degrees of freedom is 2. So I'm eliminating D and E right out of the gate. And I have to rely on my calculator one more time. So we're going to do second vars, and then we're going to go up to chi-squared CDF so that we can calculate the values. Chi-squared is 5.67, leave the 999 alone, degrees of freedom of 2. P-value is 0.0587, which means that this is going to be significant when it's going to be alpha of 0.1, but it's not going to be significant at 0.05 as this is greater than. So there is a strong evidence at 0.10 but not at 0.05. A is absolutely true. Insufficient evidence at 0.10. No, we do because it's less than alpha. This is just completely doesn't make any sense for C, so the answer here would be A. Number 16, a geneticist hypothesizes that we have, look at that, one row table. This just simply means goodness of fit test. What is the value of chi-square statistics for the goodness of fit test on this data? Okay, so they tell you that. Random sample of 60. They will be split between blue and green, and then it will be half for brown. So it will be 30, 15, and 15. So if you actually do the math, observed minus expected, over 30. This will just give you a 0, so there's no point. 11 minus 15 squared over 15. So that'll be 16 over 30 plus 16 over 15. So that will be at least 1, because that will be 32 over 30. So that will be 48 over 30. So that's it's not even like 1.5 something, 1.6. So the correct answer here should be B. Number 17. Okay, so we have 9:3:1 ratio. Would result from this crossbreeding experiment. We have a chi-squared value of 8.04. Are the observed results inconsistent with the expected ratio at the 5% level of significance? Okay, so this one was a bit tricky when I first did this problem. So what we want to do is they don't even tell you what n is equal to. Well, actually, wait a minute, I'm sorry. So you can just add them all up and then you can just do the n value. And the chi-squared value they've already solved for me. So what's really important is that we get the p-value. So let's find out what the p-value is with the expected degrees of freedom is 3 here because we have 4 categories minus 1. So second vars, and then we're going to go to chi-squared CDF, 8.04, and then degrees of freedom of 3. And so the p-value, it seems like it's 0.045. Now, with the alpha level of 5%, that is definitely less than alpha. So we have basically rejecting the null hypothesis. For the goodness of fit, what is your null and alternative? It means that the null would be that they are not going to be. They're going to be inconsistent. Like the distribution that they have, it's inconsistent with the probability, and then it's going to be the same. If I just review check back for the goodness of fit. So for the goodness of fit, the null hypothesis would be that they're going to be correct, and then the alternative will be then they're going to be incorrect here. So if we want to find out the rejecting the null, saying that they are not correct because the alternate hypothesis says they're incorrect. Are the observed results inconsistent with the expected ratio at the 5%? Yes, we want to first say yes because it's incorrect, it's inconsistent. So C and D is out. And because the computed chi-squared value is greater than the critical value or chi-squared value is less than the critical value. So if you think about it, if I have the distribution, and if this is your critical value in which is at 5%, what we have is something that's bigger than the critical value, That's why it yielded a percentage that was less than 5%. Because if this larger area consisted of 5%, what we had was something that was smaller, which was about 4%. That means our value was slightly a bit higher than your critical value, which is the dashed line. Therefore, chi-squared value is greater than critical value, so 17 here should have been A. And after I thought about this particular question for number 17, I'm not sure why this one says B for the answer key, but from what I can understand, the only possible answer for this is A, because chi-squared value is greater than the critical value that we have, which yielded a smaller p-value, which made it less than the alpha, which is therefore why we were able to reject the claim. Are the observed results inconsistent? Yes, absolutely. They're inconsistent because p was less than alpha, and in order to get p is less than alpha, we have to get a chi-squared value that is greater than the critical value. Yeah, so for 17, my apologies, but I cannot give you a clear explanation as to why it says B for this, but I believe that it should be A. But either way, even if you show up this question, this is the best possible case scenario. And remember, you don't have to get every question right. For this one, I believe it should have been A. Yes. And without any further ado, let's move on. Number 18, sophomore, junior, and senior students at high school will be surveyed. And that means we have 3 different types of grades that we have. Increase the extracurricular student activities fee. There are 3 possible responses to the survey. Agree with the increase, do not agree, or no opinion. A chi-square test will be conducted. So that will be 3 of different types of opinions. So that's 2 times 2, which is 4 for degrees of freedom. Next question, we want to find out the expected number of respondents age 30 to 50 prefer green. So I'm going to highlight green and 30 to 50. 108, 99, 314. 108, 99, 314, that's A. Very easy stuff. Which of the following procedures would be most appropriate to use for investigating? So remember, we have different types of categorical things. I mean, we have a 2A table. It's not going to be any of these. So is it going to be a goodness of fit versus independence? Obviously E, because this is always one-way table. And we clearly have two-way table, and we have one type of random sample, which is a vehicle type. We'll just get all the vehicles. So this one here should have been E, number 20. All right, let's do some free response questions here. So after getting trounced by your little brother's children's game, we have rolling it 6 times, run the appropriate chi-square test at the 0.05. So do these results cast doubt on the die's fairness? First of all, let's do the null and the alternative. This is going to be a goodness of fit test because we only have a one singular one-way table. And to go back, goodness of fit basically states that the null should have been that it's going to be correct, the distributions that you have, and then it's going to be incorrect. I am just abbreviating this a lot, but to specify the number of counts for the roll that you have for the face 1 through 6, the distribution is correct. I'm going to just give a little bit of more detail. The specified distribution of the categorical variable is correct. And for the incorrect one, the specified distribution of the same thing is incorrect. Okay, so let's try to put this into a list. First of all, we have 60 times, so we have 10, 10 throughout the whole thing, and we're gonna run through a test here. First, we need to put this into a list. We have 11, 7, 9, 15, 12, and 6. Then we have 10 throughout the whole thing. Test, chi-square, goodness of fit. We have list 1, list 2. Degrees of freedom will be 5 because there's a total of 5 different, 6 different sides to a die, and then you subtract 1. My p-value becomes 0.34 with the degrees of freedom of 5. And yes, I do realize that I did not do the planning, but we can do planning really quickly. We have rolling a die, which is automatically implied that it's going to be randomly distributed. It's going to be fairly 1/6 chance for each of the sides. We have the 10%, which is there's going to be more than 600 rolls for a die that you can make. And then each expected count is greater than 5. As you can see, they're all 10s. So checking is done. The stating is done. We've already calculated it 0.34. P is greater than alpha, therefore we fail to reject the null. This means that there isn't convincing evidence that the specified distribution is incorrect. So we first have to state that we failed to reject the null. Then secondly, we say there isn't convincing evidence. There is not a convincing evidence for the alternative, which states that they're going to be incorrect here. Number 22, many popular business franchises, think McDonald's, the owner of a local franchise benefits from the brand recognition, national advertising, and detailed guidelines provided by the franchise chain. In return, he or she pays fees to the franchise firm and agrees to follow its policies. The relationship between the local owner and the franchise firm is spelled out in a detailed contract. Okay, one clause that the contract may or may not contain is the entrepreneur's right to an exclusive territory. This means that the new outlet will be the only representative of the same chain in a specified territory and will not have to compete with other outlets of the same chain. How does the presence of an exclusive territory clause in the contract? Okay, there's a lot of detailed things. I'm just going to go straight to this. Again, they're asking you to run a test. Do you believe that there's going to be an association between exclusive territory clause and business survival? So, carry out at 0.01. We have a test for an association. So we're not testing for homogeneity. We are actually testing for the independent/association. How do you know when to use it? Well, remember, this is based on 170 new franchise firms. This is just one random sample. And they said yes or no for success. That's a category based on only one random sample. Each of those successes, yes and no, those are not two independent random samples there. So, stating H sub O, there is no association between exclusive territory clause and business survival. And H sub A is just going to be the same thing, but that there is an association. Okay, blah, 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 blah. Just to verify for the association, we are going to have, yes, so there's no association versus there is an association. For planning, do we have a random sample? Check. That's a random sample of 170. Do we also have the 10%? There's going to be more than 1,700 franchise firms, I believe. And also the expected count of every single one of them has to be greater than 5. Well, to figure that out, you actually have to create another table that clearly states the expected numbers. We have the observed for every single one of them. Now we actually need to calculate these. And it's actually ideal for us to have this table ready. So the total for yeses of the success and the total for yeses of exclusive is 142. So 142 times 123 divided the total of 170, that gives me 102.74. 123 times 28 divided by 170, 20.25, 8, let's say. 142 times 47 divided by 170, that's 39.259. I should just make that into 9 just to round it up. 47 divided by 170, that's going to give me 7.741. Okay, so now I have all the expected count, and there, look at that, they're all greater than 5, so that's also checked. Do portion. So we have we are constructing chi-squared test for association, and we are going to simply say that the degrees of freedom here are going to be 2 minus 1, 2 minus 1. So degrees of freedom is actually going to be 1 here, but we're going to verify that by using our calculator. The best way to do it is obviously go to the matrix, second x to the negative 1, edit, 2 by 2, 108, 15, 34, and 13. Matrix 6 again, and then we have 2 by 2, we have 102.741, 20.259, 39.259, 7.741. Then stat test, chi-square test, and then we press that, and then there we go. P-value is 0.015. Now, degrees of freedom is obviously 1. Seems like that is still greater than 0.01. So, we fail to reject the null. We do not have convincing evidence that there is an association, blah, 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 between the exclusive territory clause and the business survival. So you're just gonna copy and paste the alternative hypothesis right there. And just to save time, I'm gonna leave that for you guys to do. Number 23. Again, we have a two-way table. Does there appear to be a difference in the number of concussions? So take a look. They're asking for a difference. This is a chi-square test for homogeneity. And we have the null, we have the alternative. The null would be is that there is no difference. Blah, blah, blah. And then there is a difference. Guys, I am abbreviating this a lot, but make sure that you guys put in the context there for me. And with that, we have planning section, random, check. Why? Because we have a independently selected samples of 91 players, 96 and 53 non-athletes. We had, okay, it doesn't seem like there's the word randomness there. The following table is a result of classifying each student in the independently selected samples of 91 soccer players according to the number of previous concussion the student reported on a medical history questionnaire. So here, the players actually have to have the number of concussions. So we can safely assume randomness because the people who actually do get concussions, that's not, the element of randomness is still involved with the concussions that these players get. It's not like they happen in a systematic manner or anything like that. So randomness is checked because the players are selected only according to the number of previous concussions, which holds the element of randomness in there. We have approximately 240, but we have each independent random samples of 91, 96, and 53, but still we have a greater than 2,400 student athletes, I believe. We are, called student athletes who are playing these sports. And each expected count has to be greater than 5. So that is where it gets really annoying to do. This is going to be a 4x3 matrix, which we still have to create by taking all the rows and all the columns and multiplying them and doing all of these things. So even though it's going to be very tedious, we have to do this. Otherwise, we can't really solve for these types of questions. This is the most tedious part, but it's not that bad. 158 divided by 240, one at a time. So 59.9. I'm just going to abbreviate it to the nearest tenth. 45 divided by 240. 17.06 or 17.1, I would say. 22 times 91 divided by 240, 8.3. 15 times 91 over 240, 5.7. 158 times 96 over 240, 63.2. 45 times 96 over 240, 18. 22 times 96 over 240, 8.8. 15 times 96 over 240. And that's 6. 158, 53 over 240, 34.9. 45 times 240. Oh, I'm sorry. 45 times 53 over 240. That's 9.9. 22 times 53 over 240. 4.9. 15 times 53 over 240. All right, so that's 3.3. Okay, so it seems like we clearly have a number. Oh, actually, wait a minute. We might have made a mistake with 45, and I'm supposed to do 5 times 53 over 240. Right, so these numbers are not correct. So that's 1.1, and that's 3 times 53 over 240. That's 0.7, and the last one here should just give you 0 because that's 0 right there. So each of the different categories, they actually do not give you something that's bigger than 5. So if I just check my answer key at the very end, so they are not actually greater than 5. Even though they say that, they actually proceeded with the test, proceed with precaution, they said. My suggestion is that even if they give you something like this, they're still going to ask you to proceed with the test anyway. So at the end of the day, we still have the table. So let's put everything in here into the matrix and then solve for the p-value at the very least. So that's 3, that's 4. Okay, and then the second matrix, which I'm going to label it as matrix D. 59.9, 17.1, 8.3, 5.7, 63. Oh. 63.2, 18, 8.8, 6, 34.9, 1.1, 0.7, and 0. All right, so tests, we are gonna run chi-square test. The matrix here would be C versus D. And so my p-value is 0.011, chi-squared value is 22.02, and degrees of freedom is obviously gonna be 6. And my p-value is extremely low than alpha because alpha is gonna be a 0.05. So we definitely reject the null hypothesis. Reject null hypothesis. We do have convincing evidence that there is a difference of the distributions, or we do have a difference in the number of concussions for 3 different types of groups of students, blah, blah, blah. Number comes, yeah. So you just have to regurgitate this context, rewrite it right over there with the alternate hypothesis that there is no difference. There is no difference between blah, 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 blah with the 2 variables stated. Okay, so just checking over the answers here real quick. We have 22. 22 was also a p-value of 0.015. So yeah, we did everything correctly there. And then for 21, with the goodness of fit tests, we have that we failed to reject the null. There we go. And p-value is 0.34. Yeah, so these are the free response questions, and I hope that this video helps you understanding it. Remember, the biggest thing I would say is to stating your null and the alternative hypothesis, because sometimes it's very confusing. There are 3. Make sure you know goodness of fit, homogeneity, as well as the independence. And thank you very much, and study hard, and I'll see you guys tomorrow.